In this video, we're going to build a cool project, an automatic night lamp that turns on when it gets dark. We'll go step by step, explaining each component and how it contributes to the overall function of the circuit. Here's the circuit diagram we'll be using. Don't worry if it looks complicated at first. We'll break it down piece by piece. The main components are an LDR and op-amp, a transistor, a relay, and a few resistors and diodes. The basic idea is that the LDR senses the light level, and when it gets dark enough, it triggers the rest of the circuit to turn on the lamp. LDR. First, we have the LDR, or light-dependent resistor. As the name suggests, its resistance changes based on the amount of light hitting it. In bright light, the resistance is low. In darkness, the resistance is high. Resistors. Next, we have standard resistors. R2 works with the LDR to form a voltage divider, and R3 limits current to the transistor. Potentiometer. RP1 is a 10,000 ohms potentiometer, which acts as a variable resistor. We'll use this to adjust the sensitivity of the circuit, controlling when the lamp turns on. Op-amp. The LM358 is an operational amplifier, and in this circuit, it's configured as a comparator. It compares the voltage at its two inputs and outputs a high or a low signal based on the comparison. Pin 2 is the inverting input, connected to the LDR. Pin 3 is the non-inverting input, connected to the potentiometer. Transistor. The BC547 is an NPN transistor, which acts as a switch. When the op-amp's output is high, it turns the transistor on, allowing current to flow. Diode. The 1in4 diode is a flyback diode. It protects the transistor from voltage spikes when the relay coil de-energizes. Relay. Finally, we have the relay. It's an electrically operated switch. When the transistor turns on, it energizes the relay coil, which switches the AC power to the bulb. This relay is a single-pole double-throw type. 1 voltage divider. The LDR and R2 form a voltage divider. The voltage at the junction of R1 and R2 depends on the resistance of the LDR. In bright light, the LDR's resistance is low, so the voltage at the inverting input of the op-amp is also low. In darkness, the LDR's resistance is high, increasing the voltage at the inverting input. 2. Comparator. The LM358 op-amp compares the voltage at its inverting input with the voltage at its non-inverting input. The potentiometer sets a reference voltage at the non-inverting input. This reference voltage determines the light level at which the lamp will turn on. When the voltage at the inverting input is greater than the voltage at the non-inverting input, the output of the op-amp goes high. This high voltage is applied to the base of the BC547 transistor through resistor R3, turning the transistor on.